Okay, we're about to get started here. Again, as per usual, if you want to get a hold of me throughout the live stream, send a message via the live chat, send a message via email or via Edsby. I'll be checking those throughout the course of the live stream. Hopefully the audio is now working this time. I know it's been an issue a bit in the past. Still not sure if it's just maybe it's my cheap laptop or old microphone or my terrible Wi-Fi. But we're looking at the section on quadratic relations, the form y equals a times x minus r times x minus t, or vertex form, or factored form, or a zeros form. And so we're going to work on those questions today. Again, if you have specific questions that you want to take a look at, let me know in the chat. Let me know in the messaging or any of our messaging, Edsby, or via email. Okay. So if we get started, some good ones I think to look at would be something like number 3b. And in the case of 3b, switch over here, we're looking at the y equals negative, and then in parentheses x plus 3, and then the other parenthesis x plus 7. So these are the this is already set up for us in zeros format, and what we want to do is sketch the parabola, labeling the x-intercepts and the vertex. And so I'm just going to copy that down for myself here. Okay, and x plus 3, x plus 7. So there is the equation, and what we want to do is we want to go through and graph this on just a quick sketch. And so I'll do a quick set of XY axes, and we want to put a few key points there. We want the x-intercepts and the vertex. So we can find the x-intercepts, x plus 3, x plus 7. The x-intercepts are the opposites of those. So negative 3, maybe about right here, and negative 7, maybe somewhere over here. And now the vertex, we know it's opening down, so it's going to be something like this, but we're not given the vertex. So to find the vertex, what we need to do is just a two-step process. Find the middle of these 2 points. To do that, we can find the h value of the vertex, the middle, by taking negative 7 plus negative 3 and dividing that by 2. We can average them out, and that would give us an h value of negative 5. And so we know the vertex is going to be at negative 5 here in between. And then to get the y value, or the k value of the vertex, we just sub that into the equation. So we were looking for the k value, which is the y, and then a negative, let's rewrite that a little cleaner, negative 5 plus 3, and negative 5 plus 7. So there is the equation. We just have to simplify that, and that will give us our zeros. So negative 5 plus 3 is going to give us negative 2. Negative 5 plus 7 is going to give us 2. And then our k value is going to be negative times a negative is a positive. So that's 2 times 2, or 4. So our k value occurs at 4. So our vertex is 5, 4. So there we've labeled our zeros, and we've labeled our vertex in the case of that question. In the case of the next one I want to look at, it's number 4a. So 4a looks a little bit different. We're doing the same thing. So in 4a we got y equals 3x times x plus 2. And we want to do the same thing. Sketch it, label the x-intercepts, and vertex. The problem here is that we don't have the same looking thing. It's not exactly explicitly in the brackets. So what does that mean? Well, I could modify this equation in such that I could make it 3 times x plus 0 and then x plus 2. That would give me my two zeros. So I can use that. X is going to be 0, and this other one's going to be negative 2 as my two x-intercepts. So when I go to sketch this, I can have one point at 0, and the other point is going to be at negative 2, maybe over here. At negative 2. It's going to be a fairly skinny graph. It's opening upwards, so I know that, but I don't know the exact coordinates of the vertex. However, again, if I find the middle of these 2 points, which by looking between 0 and negative 2, it's going to be at negative 1. I could also plug it into the equation and just add 0 plus negative 2 and divide by 2. And then I can find my y value of the vertex by just subbing that in. Y equals 3 times negative 1 times negative 1 plus 2, or y equals negative 3 times 1 times 1. And so in that case, I just get a y equal to negative 3. There's my vertex at negative 1 and negative 3. And so even though it's not written in that same format that we're used to with the two sets of brackets, when the x is by itself like that, we can just treat it like it's x plus 0 in a bracket. That'll allow us to solve that. So that is looking for the vertex given the zeros, and then you can plot that, getting some of those key values. Another one I wanted to look at was number 5. So if we switch over here and look at number 5. Number 5 says determine an equation in the form of y equals a x minus r x minus x to represent each parabola. Consider the vertex and the x-intercepts in doing such. So if we look at the a equation here, that's the blue one, then we have a couple points. We have zeros at negative 7 and 0. We have a 0 at negative 3 and 0, and then we have a vertex at negative 5 and negative 2. So if I work on that one, my vertex at negative 5, negative 2, this is 5a, we have the x-intercepts at was negative 7 and negative 3. So that was the information that graph gave us, and from there we can create an equation in the form of y equals a x minus r. They use s. I'm going to use t because my t's look like my s's look like 5s, and then I can sub in these values that I have. So y equals a x, negative 7 will be plus 7, and then negative t will be plus 3. So that'll flip those signs around. Now I need to find my a value. Well, I'm given an x and a y value here. I can sub those in. Y is 2, a, and then my x value is negative 5 plus 7, negative 5 plus 3. Simplify that down. A, that'll be a 2, that'll be a negative 2, and so we have negative 4a on this side. Divide that out, and we're going to get negative 2 over negative 4 equal to a, or a equals 1/2. And then that will give us our equation. Y equals 1/2 x plus 7 x plus 3. And then you do the same thing in the case of the b to find that. I see a question regarding exams. At this moment, we are, it was announced yesterday that we are not going back until at least the end of May, if it doesn't get extended longer. So in regards to exams, as of right now, I do not believe there are going to be any exams. Do not quote me on that 100%, and I can look that up and verify that. But as of right now, I believe that we are not focused on doing exams. If we do go back in June, there may be an opportunity to do that. But if we don't go back, I'm assuming that we will probably not be completing exams. But again, that is not 100%. I would wait for confirmation from the... I haven't heard that directly from the Ministry of Education, and that's who's making those decisions, so I would wait to hear from them. Again, if you guys have questions, specific questions you want me to take up, we can do that. Otherwise, I'm going to do one more question here, and that should kind of cover the different types of questions that we have, and that is number 10. Switching this all around here. Question number 10 says that a soccer ball is kicked from a point 23 meters to the left of the halfway line and lands at a point 17 meters to the right of the halfway line. It reaches a maximum height of 10 meters during its parabolic flight. Sketch a graph to show the flight of the soccer ball if the halfway line passes through the origin. Recall that the origin is the zero value. It's the intersection of the axes. So that is the 0, 0. So that's our halfway line. And then determine an equation to represent the path of the ball. So switching back over here. So in number 10 there, we were given that it's 23 meters to the right, to the left. And then it lands 17 meters to the right. And the max height was 10 meters. So given these two pieces of information, or three pieces of information, we can actually create ourselves a sketch, and then we can, so this is number 10, we can then, from that sketch and information, we can create ourselves an equation to represent it. So I'm going to do a sketch here, set my axes up. I know the balls are not going into the negative values because the ground here is going to be the base, so that's going to be my x-axis, or in this case here, it's going to be my distance the ball's traveled, and then I'll call this my h, or the height of the ball. So it starts 23 meters to the left. So if I go over to the left here, say about right here, we'll call that 23 meters. It lands about 10 meters to the right of that halfway line. And so then it's going to hit a max height of 10 somewhere. So our max height maybe right here, we'll call that 10. But I don't know where that max height is. That halfway line doesn't mean it's the midpoint of the graph. It means it's the midpoint of this field per se. And so that halfway line represents just a position that we're basing off for the kick. But the actual midpoint, or the vertex of this graph, is in between 23 and 10. So to find the vertex, and this is for part B because we want an equation, the vertex is going to occur midway between 23 and 10. So 23 plus 10, sorry, negative 23, right, that's on the negative side, divided by 2. So negative 23 plus 10 is going to be negative 13, and half of negative 13 is going to be negative 6.5. So that's our midway vertex point there. And then we have the y value of the vertex already. We have our two zeros, and so now we can create our equation in the form y equals a x minus r x minus t. And we can fill in the vertex values for y and x. We can fill in the 0 values for r and t, and then solve for a. So our y value of 10, a, our x value of negative 6.5, r can be plus 23, or positive 23, because we use the opposite. Negative 6.5 for our x, and then again, opposite of positive 10 is negative 10. And so we'll just work this out, solving for a. And then that will give us will allow us to create our final equation. So we have negative 6.5 plus 23, getting us positive 16.5. Negative 6.5 minus 10 is going to give us negative 16.5. Multiply those together, and we're going to get 10 equals 272.25a. We divide 10 by 272.25, and we can actually convert this into a decimal because we have a decimal in the fraction. It doesn't look very nice. 272.25. So it's approximately, this is not exact, but a is approximately 0.4. So that's our a value, approximately 0.4. Now we can sub all that in and get our equation. Therefore, y equals, and that should be negative, sorry, that would have been negative 272.25, so that would be negative, thus that's negative. So y equals negative 0.4, x plus 23, x minus 10, and there we have an equation to represent the path of the ball. When we're working again with these zeros, again the key thing here is that these are going to switch signs when you pull them out and put them on the graph. In the next unit, which has been posted, I posted the whole unit. It's not a rush thing, just it's up there for those of you that are ready. We'll see why, and we'll do some solving of these quadratics when they're in zeros form and factored form. Again, if you have questions that I didn't cover, shoot me a message on Edsby via email and let me know, and I will try and keep you updated, or I'll try and help you out with them. And I think that's about it for today. Again, make sure you're asking questions when you have them.